Uh, Guys, if you have any questions during the session, just put it on the chat and we will answer it from there.
Okay, so let us start. Uh, so, hello everyone. Today we are starting that automating stuff with C++. This is going to be a rather introductory level of C++ programming, which is being put in slightly unconventional way. Okay, so today I will take a little bit of time for setting up the expectations, as in what you should be expecting from this entire series and what you should not be expecting from this entire series. Okay, so for starters, this series is not going to get you good marks in your university exams or some sort of certification exam, right? So if you are looking forward to crack some sort of exam after going through this, the course material will not really align with what you can expect from a certification course or some university or semester level course. So that is one part. Second is, although I will recommend some books that I expect you to get a copy of and follow in parallel as a reference material, the order of topics is going to be slightly different in some places and wildly different in some other places. Okay, so there will be cases where there will be topics which will be covered very late in most of the popular books, but we will be covering them pretty early, and we will be taking some very early topics in very late in the course. Okay, and we are going to do this because the intent is not to teach a lot of nitty gritties of C++, as in C++ has these 10 types of different things, and let us learn something about all of them. The intent is to teach you language in a way where you can be somewhat productive after using the C++ to solve some problem from your life. Maybe you want to automate some file related stuff. Maybe you want to automate some sort of network related stuff. Maybe you want to automate interacting with some sort of web service or some other network service. Or you just want to crunch some numbers, process or parse some data, something like that. So the intent is to get you to the stage where you can start doing that part in C++ reasonably comfortably. Okay, so that is what we are going to do. Another difference is going to be that most of the books that you will find either online or on common bookshops, those will be written for slightly older version of C++. Okay, and if you start finding or rather hunting for books which teach modern C++, those are mostly written for people who already know C++ quite a bit, right? So if you start directly from a book geared towards modern C++, you won't really be able to use it fully because you lack the background of C++ before getting into the book. And if you take some other book which is going to be helpful for a beginner, you will not really learn a lot of good things which is part of C++ now, but it was not part of C++ back then. So these are some of the things, and as we progress in the course, I will keep giving you specific pointers that this topic can be studied further from this book, chapter number so and so, or possibly some online resources as well. There will be some practice problems. There will be some problems which we will do live in the session. There will be some other practice problems which I expect you to do between the sessions, as in somewhere between Sunday to Friday. And although none of the practice problems are going to be evaluated in any shape or form, as in I am not going to ask you to submit them somewhere, and I am not really going to grade your solutions on any parameter. Okay. Even then, I want you to do them so that you get at least some practice on whatever concepts we are covering in that particular session. Okay, and that is way more important because if you do not practice this, even though the problems may feel like quite boring one or a bit too basic one, or at times it will look like pretty wacky one, even then you have to practice it, because C++ as a language requires a little bit more practice on your part, so that you can finally start grasping the concept that, okay, now I understand this part and I can use this particular concept pretty much anywhere I want now. Okay, so there is that, and with that we can start with it. And if you are following along, I will be focusing more on Linux-based tooling. Okay. For as far as the course is concerned, you can follow it on pretty much any platform. You can follow it on Windows, on Mac OS, on some other flavor of Linux. But for my series, I will be doing pretty much everything on Linux. Okay, so that is one part. Second, to follow, you can set up, we will talk about a bunch of toolings, but again, I will be only talking about toolings on Linux platform. I will briefly mention the toolings for macOS and Windows as well. I will also give you links where you can find those toolings, but I will not be covering how to install or configure that tooling for any platform. That is for you to figure out. And I will share some decent write-ups for each platform where you can follow the steps and set up tooling for whatever platform you want to deal with. But if you decide to follow on some other platform, there will be various differences. For example, if I am following on Linux and I'm using some particular IDE and I want to basically link with some other third-party library, which we will be doing somewhere in the series. For me, the process will be different. I will be basically installing via command line, using a package manager, adding a couple of lines in build system to basically configure the compiler for all that fancy stuff. For you, those steps may be wildly different, especially if you are following using some completely different IDE. Okay, so these are the differences that you have to keep in mind. So where there are differences due to platform, due to different set of tooling, or due to different types of IDs, different compilers, that sort of stuff, that is where you have to basically figure out how to deal with differences on your own. I will not be covering any of that. So if I say that, okay, we are going to install this library, I will be doing that on Linux. I will not cover how to install that on Mac OS or Windows. I will give you URL where you can find the project. I can probably give you link of installation page where the project has outlined how to install it for whatever platform they want to deal with. But actual installation, and if something goes wrong, how to fix your installation part, that is something that you have to do on your own. To some limited extent, I can probably take some questions on that and try to figure out what is going wrong. But again, absolutely no guarantees on that part. So you will be on your own. So for the series, what I will be using, I will be using Linux, specifically Ubuntu, and I'm using 24.04 LTS. In case you want to copy it exactly as it is, I am going to use C++ compiler for this GNU, that is packaged as G++. And for debugger, I am going to use again from GNU packaged as GDB. For build system, I am going to use CMake and make. Okay, so if you want to install it on how to install on Ubuntu, you can use something like sudo apt install g++, gdb, make, cmake, and it will basically install everything. Okay, now for IDE, why do I need IDE here? IDE is basically integrated development environment. So the some this is stuff that you are seeing on my screen is basically IDE geared towards C++ development. And point of using an IDE instead of using something else is because it integrates a lot of nice functionalities in one place. Okay, I want to modify my code. I can do it entirely within IDE. I want to debug some code. I will be able to do this entirely within my IDE. I want to do local development, remote development, some other stuff. A lot of things are going to be neatly integrated within IDE. I want some sort of syntax highlighting, color coding, autocomplete. So all those goodies come inbuilt with IDE, and that is the point of having an IDE, right? If you do not want to use IDE, you can probably do it on command line, or you can use probably some plain text editor with some basic syntax highlighting. It is entirely up to you. So as far as I am concerned, I am going to use ID from this, and this is the ID name. This is the company. If you do not want to use this, possibly because this is not really a free product. So for alternatives, you can use other IDs. I will list those as well. So these are basically the toolings which I am going to use. Okay. Now I am going to list a couple of alternatives that you can use. So I will start from Windows. So what you can do, you can set up either Visual Studio itself, okay, and this will come with IDE, compiler, debugger, all three, assuming you select all the components for installation. Otherwise, you can set up VS Code with plugins, and for that you will need for C++ development, debugging, etc. Okay, and if you want specific compilers, you can use MSVC itself, that is Microsoft C++ compiler, or maybe you can use LLVM for Windows. I think it is available now, or you can use MingW. That is basically Windows build of this G++ thing. Same compiler, just for packaged for Windows. But if you are sticking with Windows, especially with Visual Studio, I will say stick to MSVC or maybe LLVM part, because this is now supported in Visual Studio right out of the box. Now for Mac OS, if you want, you can probably use Qt Creator. This is C++ IDE, but it will not come with compiler. So for that, for compiler and debugger, Xcode with its CLIs. So you will have to install Xcode, and then you have to install all the utilities that comes with it for your Mac OS development, and that will pull the compiler, debugger, and bunch of other things on your Mac OS, and then you can probably use Qt Creator as IDE, or probably you can use VS Code for Mac OS as well. Okay. Now, for cross-platform, if you do not want to deal with different IDs or different platforms, Qt Creator is one. It is available for Windows, Linux, Mac, all three. VS Code is another, again available on all three. And JetBrains CLAN that I am using, available for all three. But this one is not free, as in you will have to shell out some money if you want to use it. Okay. Okay. Any questions so far? Anyone wants to ask something?
You can post questions on Q&A.
Sure. I will
My
just wait for a minute here. If you have any questions so far, just start posting in Q&A. Okay, so there is a question on any prerequisites. Yes, the prerequisite is that you should have prior experience in programming in at least one other language. If you already know Python, it is fine. You already know C Sharp, Java, some other .NET language, it is fine. The only prerequisite is that you should have some prior information, at least some prior exposure to programming, because then it will be pretty easy to follow C++. And the reason is why you need some prior programming experience, because other languages are geared more towards programmer doing some useful things right out of the bat. C++ is not really geared towards that. C++ is more like amalgamation of basically a khichdi of bunch of wildly different languages packaged into one, where there is something for everyone. You are someone who wants to play at hardware level, you want to deal with embedded systems, there are things for you. You are someone who is writing third party libraries, frameworks, that sort of stuff, there is something for you. You are someone who is going to write a lot of network based services, backend services, there are things which are going to be useful for you. You are someone who is going to write malware, to figure out exploits, possibly automate exploitation. There are things which are going to be useful for you. You are someone who does not really care about any of that, and you only want to write some applications. There are things in C++ for you. You are someone who only is interested in automating stuff. You don't want to write entire application from start to finish. You only want to automate something. There are things which are going to be useful for you, right? In other languages, those many features are not really present, and the end result is that if you start with C++ as first language, there will be a lot of oddities which will not really make any sense to you. Okay, because you will feel like that, okay, this is not really the best way of doing thing for computer programming, and you will be all right, except that the thing is not really geared for someone who is an absolute beginner in programming. So this is a deliberate trade-off. By not catering to absolute beginners in programming, we end up catering to a lot of different groups of programmers who are going to be interested in a lot of different things. Okay, so that is why you need some prior experience with at least one other programming language. Okay, there is one more question. Can we use Docker container-based environment for development? Yes, yes, you can. Can we know the duration of this course? It is going to be roughly 2 months. Depends upon how fast or slow we are moving, but somewhere around 2 months. So by end of Feb or at least early March, we will be wrapping this up. Which books you recommend for beginners to learn C++ from basic? Okay, that is a tricky question. So there are going to be a couple of different books actually. For absolute basics, you can pick something from Complete Reference. I forgot the author's name, but that used to be really popular book available pretty much everywhere. So in that Complete Reference series, there are a lot of books on different programming languages. Pick one on C++. And if I remember correctly, it covers C++ 11 reasonably well. So you can start from that book as a beginner, and then you will need couple of more books possibly. One is called C++ Primer. I'm not sure if you are able to, if you are going to get hard copy offline, but it is available online. So you can order either hard copy or ebook format. Both are available. And C++ Primer is much better than Complete Reference. But again, C++ Primer is not really geared towards absolute beginners. So ideally, I will
Mr.
say
Ji,
yes.
what we're gonna do is you're gonna create a GitHub notes and
Okay.
or internal notes and share with all the participants. Right. There are a lot of
Yeah.
books that we can refer to. That will be easy for everyone to follow from there.
Oh, yes, yes, yes. We can do that. Okay, so any more questions or can we proceed here? I think we can proceed. There are no more questions. Everyone is talking about books. Okay. Now the basics are sorted, expectation is set, so we will start from C++ itself. Okay, so it is basically a compiled language. Okay, and compiled language means that it is not really run in source format. You write the source code, you use another tool called compiler, and it will basically process your source code and spit out another binary blob that will be an executable, and you can basically run the executable directly. You don't really need source code after that, unless you want to do some modification. Okay, so you don't have to distribute the code, you only have to distribute the compiled binary. Okay, and it is cross-platform. And when I say cross-platform, it is basically cross-platform to rather ridiculous extent. It is going to run on basically everything from microcontrollers to spaceships and basically anything and everything in between. You are taking a flight, your flight is possibly running a lot of C++ code. You are driving a car and your ECU is going to run a lot of C++ code. You have some smart appliance, some smart fridge, a smart oven, a smart toaster, a smart washing machine, something like that. And chances are pretty darn good that your smart appliance is running at least some non-trivial amount of C++ code. Okay, you are making a phone call, there is going to be C++ involved. You are making a video call, there is going to be C++ involved. You are doing media encoding, you are doing Netflix and chill. It is going to involve C++ in non-trivial amount of work. So it is cross-platform to rather ridiculous extent. Okay, and obviously that means that we can use it for Windows, Linux, Mac, basically anywhere. Okay, and the motto here is for this language, uh, oh, trust the programmer. And this is against most of the common languages that you see in your career. What I mean by trust the programmer is that if you take some other languages, there will be things which will explicitly not be allowed. Okay, you create an array, you cannot really push more data inside it than you basically claimed that you will. Okay, if you said that okay, I will only keep 10 items here, you are not going to be able to show 11th item there. In C++, that is not the case. It is completely open. If you want to show 11th item there, it will happily let you do so, consequences be damned. Okay, because here you are trusted as a learned person that you know what the heck you are doing here. The end result is that if you do not understand the system in general, you are going to do a lot of naive mistakes which will look trivial on surface, but they will end up having rather serious consequences. And that is why when you see in the news that, oh my God, this is unsafe language, this is why, because the motto is trust the programmer, no questions asked. If programmer wants to show 11th item in a place where only 10 items can be stored, consequences be damned, show that item. Except the consequences are not really nice to deal with, but again, this is a language where you can expect a lot of oddities because of the motto which is going in completely opposite direction. So that is there, and as usual, we will start with a very minimal template of the program. Okay, so wait. Okay, here it goes. A minimal C++ program. So what it looks like? It looks something like this. Okay, so this is basically absolute minimal amount of C++ that you can write that will actually do something. Okay, and what we are going to do here, we are just going to print hello world, and there are some specific parts of this program. So uh, here, this topmost line that you are seeing, this is basically saying that we are going to include some libraries. We in beginning we include some libraries because reusing better than writing everything on our own. Obviously, we are engineers, we are going to be lazy. Okay, so this hash include basically says that, okay, this is a library in angle brackets, and please find the library and attach it with the program that I am going to write after this. And that also means that whatever library we are going to include here, we are also possibly going to use at least some of the functions from that library in rest of the program. Okay, then we have this particular line, and it is basically a function, and it is a special function. So uh, it is an special function, always named main. This is where program starts its execution. So in our more realistic cases, there can be thousands and thousands of different functions scattered around hundreds of different files, but execution is always going to start from this main function. Okay, this is where your program's life starts for pretty much all practical intents and purposes. Okay, which means that whatever you want to do, it has to start somewhere in the main. You start here, then you can probably call other functions from within the main, and then from those functions, you can call some other functions ad infinitum, and you will eventually be able to do your thing. Okay, so this is something that is going to be in all C++ programs. Then here we have this special line, uh, returns 0 to parent process as exit status. Okay, what does this mean? That if you run a subprogram, as in you wrote a program, and from there you start some other process, right? And then you let it do its thing and you collect its exit status. Generally, what happens that you can use the value that you are returning here to infer something about success or failure of that particular process. For example, let us say you write some sort of automation. There are multiple moving parts, and from one program you want to infer whether the other program succeeded in doing that or not. Maybe you are trying to parse JSON and you want to know whether your another utility was able to parse JSON properly and extract data or not. So you can signal it from here as long as you return different value for different type of success or failure. So possibly if you are reading the file and you are unable to read the file, maybe path does not exist or there is permission issue, you can return probably one, or a path exists but it is blank, you return two. It is not blank, but it is not JSON either, you return three. It is JSON, but the desired fields are not present there, return four, so on and so forth. So from other process, if you monitor this exit status, just by getting this value and mapping it with the expected values that you are supposed to get from that utility, you can infer that, okay, probably this thing went wrong with this particular utility, right? So that is where this thing comes handy. This is basically a very crude signaling mechanism across processes. Now, above that, okay, so this is also where your function will end. So if you write something after here, anything you write after return 0 will not be executed, because this is where this function basically returns. It completes its life cycle, and as soon as main is over, your process will basically terminate because there is nothing else to do. So if you write something else here, that will simply not get executed. Now, before here, we have this special line, and again, there are multiple parts. It is basically prints hello world on standard output. That is going to be your console in most of the cases. Okay. Now there are multiple parts here. So there is this thing std cout that you see here. Okay. And this is basically this is your console. Anything you send to it appears on your console. Okay. This is an operator, and you can think like that this string is being sent to cout because this angle is pointing towards console. Okay, so operator sends some data to console, or okay, for this case it is going to be console. Okay, then again this is here, and then we see this one. So endl, it says end of line or new line. Anything that comes after this will appear in new line. Okay. Now here you see this one. So this end of line is not being sent into this string. It is more like that this console is going to get this and this both. Similarly, we can have a chain of something like this, some other strings or numerics or some other stuff, and everything will eventually go to this console and it will be printed on your console in some format. Okay, so if we compile and run this, we can expect that this hello world string will appear on your console. So what I am going to do, I am going to build it. Okay, so here I see that build is finished. So what I will do, I will just run lecture one because, well, this is the binary here. Okay, so here it built it, it ran, and here I see this hello world string being printed. Okay, so this is the bare minimal structure of a C++ code. And now the obvious question is that, okay, I gave you this particular code and I gave you a quick demo that, okay, yes, this is how it is compiled and run. But the question is, how do you do it at your own end? Okay, so for that, we need to do a little bit more stuff. We already covered this code. Okay, and what we will do, how to build and run C++ program. Okay, so option one is, so the step one is write C++ program and save it with .cpp extension. If you see here, the name is main.c++ here that you can see it. So this extension is kind of going to be there. Compile it, execute the output binary. Okay, now compilation. We have, for compilation we have multiple options. How to compile? So option one is we can specify G++ here source file dot C++, and then we specify the output compiled dot elf, or maybe for Windows it is going to be exe or something like that. Okay, and then we just run it. That is option one. Okay, now I think I can give you a rundown of how this works. Okay, where is it? digit A7. A7 CMA. Okay, so what I can do G++, go to lecture 1, main.cpp -o, and say I want to just put compile.exe here. So I see no output. That means it compiled without any error. If I do ls here again, I will see this new file has been created. I can run it here and I see my output. Okay, so that is option 1. But the problem is that if you are doing like this, you are probably not using any ID or not using ID efficiently. If you are someone who lives and breathes in command line, it is fine. Second option is use a build system. Okay, now a build system is another set of tooling which basically deals with finding appropriate command lines for compiler like this one. Okay, and it will basically invoke a compiler for you and it will generate all the compiled binaries. Okay, so it is most useful when you are going to have basically multiple binaries part of same project, or your source code is scattered around multiple files because it is large in size, that sort of stuff. Okay, now obviously you can either compile everything manually using G++ directly, or you can probably write a one-liner huge command which will do it every time you invoke it, or possibly wrap it up inside some sort of a script. But the catch is that if you modify only one file and if you use that manual method, you will be compiling every file which has not changed as well. Okay, since we are lazy and we want to get things done rather quickly, we ideally want to cache the results of files which are not modified, and we only want to compile the part of program which is actually modified. Okay, now this part is something that becomes tricky to do manually. You can't really expect to keep track of that. Okay, this time I modified this particular file, so I will only compile that, and I have kept the cache in some other folder. Then I will find something from that cache and start linking everything together. That becomes ridiculously complicated very quickly. Okay, so we just nuke all that out of existence, and we involve something called build system that is already going to do all this and a lot of other stuff for us, so that we can focus on writing the code instead of trying to figure out how to compile everything together in a nice way. Okay, so the build system compiles your C++ project, can handle multiple sub-projects, can handle dependencies between sub-projects, as in you have 10 different sub-projects, 8 out of which are basically libraries, 2 of them are programs. And if there is dependency, you will have to build them in some specific order. And for that, you have to figure out all the dependency part manually once again. With build system, you don't have to do any of that. You just specify that, okay, this is a dependency of that, that is dependency of something else, and you are going to do it only once. And rest of the stuff will be figured out automatically by the build system. Okay, so can handle parallel compilation. This is something basically if you have 10 different files and you have rather beefy CPU, say you have 4 cores that you can sacrifice for compiler. So build system will happily invoke 4 copies of compiler with 4 different files running in parallel and compiling together. So this is something that your build system can do on its own. Okay, then it can also handle external libraries, as in many times it can find those libraries for you, so you won't have to find the exact location of those libraries in the system. You will just tell the build system that, hey, I am going to use, say, Boost. Now find Boost somewhere on my system and link with it. So it will do the job of finding something from Boost that you are actually using from your system, and it will figure out what sort of parameters to specify to compiler so that everything can get compiled correctly and linked correctly, so your resulting program actually works. Okay, so that stuff is also done by build systems. So these are the most common use cases of having a build system, and that is why if you take a look at most of the C++ program that is being written professionally, whether open source, closed source, whatever, all of them, pretty much all of them will have some sort of build system involved. Okay, someone may use CMake, someone may use Ninja, someone may use Auto Tools, someone may use some other stuff. But end of the day, everyone is using at least one build system to build everything from scratch. And the reason is that doing this manually when your code base is growing slowly becomes massive pain. So you want to basically offload it to some other tooling which can do it for you reliably. So for build system, we are going to use CMake. Okay. Our choice, it is going to be CMake. Why CMake? Because it is a ridiculously popular build system now. It can do all of these. It can even download libraries for you from internet, from GitHub, and automatically integrate it with rest of your code, so you don't have to explicitly download, compile, and install some other library. Those sort of things are already here. Plus, it can also generate build files for other build systems as well. So not only you can use CMake as a build system directly, you can also use it as some sort of meta build system. So if I am writing some sort of tool in C++ that is going to be cross-platform, and if I am using CMake, someone using Windows can use that CMake tool to generate project file for Visual Studio and then compile using Visual Studio because that is natively available on Windows. For Linux, he can generate make file and then use make, which is native to Linux, to build everything from the source code. Similarly, on Mac OS, it will generate a make file geared toward Mac OS. And then I can use the build tooling present natively on Mac OS to build everything from source code. As a developer, for me, I did not have to learn how to use Visual Studio, how to configure a project in Visual Studio, how to specify various parameters in Visual Studio, or differences between a makefile for Linux or Mac OS. I don't have to care about any of that. Okay, I only have to care about CMake, and CMake is going to handle all that dirty stuff for me. So that is also one of the reasons why it is ridiculously popular. So for CMake, what we do using CMake. So what we do, we have a file, especially named file called CMake lists.txt. Okay, it specifies minimum CMake version required because older versions may not have fancy features that we are looking for. Okay, it specifies the minimum C++ version, specifies project details. Okay, so it will look something like this at bare minimal. So here in the first line, what I am doing, I have specified that I need minimum 3.28 version for this thing to build. Okay. Similarly, here I am just setting a name. It is, well, just a name. Okay. And here I am saying that, okay, the minimum C++ standard is going to be C++ 20. Okay. And then here, what I say that after compiling, there should be one executable named lecture 1, and to build this, compile all the files that I am going to specify after this. So here I have only one file. In future, I may have 10 different files or 20 different files scattered around 10 different folders. Does not really matter. All I have to do is to specify the path in that particular line, and CMake will find all those and basically club them together and build that executable for me. It will also do something extra. Here I have specified C++ version to be C++20. Okay. Now, if I am not using a build system, I will have to manually test somehow whether the compiler that is available to me is actually supporting C++20 or not. Okay. Here I don't have to do that. I only have to specify that I want this particular C++ version, and then CMake will take care of that part as well. Okay, and it will also check whether some C++ compiler is installed or not installed. Okay, so if we want to see this in action, okay, so I will make another build folder here, cd tmp build, and what I want to do, I want to generate a Linux make file here. So I will use CMake, and then I will give path of the source tree, that is the previous folder, and it will do something. Now here, if you see, it is checking for compiler versions that, okay, this is the C compiler version that is available. This is the C++ compiler version that is available. It is also checking for whether the C compiler is working or not. It already found this one. So it skipped this. Similarly for C++, is already found this one. So this one gets skipped, right? Then it is also checking for some compile time features, whether those are available in the compiler that is available on the system or not. Okay. And then after doing all these testing, and again, this is something that I don't have to do manually because I don't control where my source code may get downloaded for compilation and installation, right? So all this thing gets automated by CMake only by specifying this particular line. And then it says that configuration is done. Then it generates a bunch of files, and those files will look something like this. Here it has generated this make file. Obviously, it will look something rather cryptic. Again, this is something that I don't have to modify, or rather, I'm not really supposed to modify it. I only supposed to run make. And then all I see that building C++ object for this particular file, and then it is generating the executable, and then it says that build target lecture 1. And here, if I see, I have my binary ready here. Okay, which means that if I'm copying some source code which has some build system, I don't really have to worry about how to build it. If it is using CMake, I just run basically this CMake space dot dot or whatever path is there, and then I simply run make. I get some output like this, and my stuff is built. Okay, so this is how we generally build the C++ code. So going forward, we are going to use CMake. You can either use CMake at your own end, or probably you can use some other build system if you are comfortable with that. But if something goes wrong with that particular build system, I will not be figuring out how to fix that because, to be honest, I have no idea about some other build system. I use CMake. Okay. Any questions so far? Okay, wait. I think there are some questions already here. Wait, give me a minute. What are the alternatives of std double colon c out? Okay, so if you're asking about printing on console, I will say stick to this std double colon console out. There are other functions which are coming from C, but those are not that nice in grand scheme of things. Uh, okay, someone asked about named pipes. Oh, okay, there is some other discussion possibly. Angle bracket is also a bit shift operator in C, C++. How compiler is differentiating it. Okay, this is part of operator overloading. We will cover this part in future. Why we are not mentioning using namespace std? Okay, so you are basically talking about putting using namespace std here, and then we don't have to type this part again and again and again in rest of the code. Well, that is basically a bad practice, because eventually you will be dealing with multiple different libraries and by extension multiple different namespaces. Namespaces are basically some sort of logical grouping of functions and classes and that sort of stuff. So if you specify every namespace directly using that using namespace line, what happens that there is risk of function with same name being present in two wildly different libraries, doing two wildly different things, and which version you end up calling becomes basically a mystery. So you expect something, you expect A to happen, but magically B happens, and then you are left wondering that what went wrong in your code, and then debugging that becomes a massive headache. So it is better that if you don't involve entire namespace using namespace line, stick to specific namespaces in specific cases. So this name collision does not really happen. Okay, not required. So the build system will look for external library in the whole system. Do we need to specify the location? It is kind of middle of that, but most of the time you don't have to specify location explicitly. And build system will not really scan your entire file system. It has some internal mechanism to figure out what are the default installation locations there, and then libraries have mechanism to basically advertise their locations as well. So these two basically talk to each other via some specially placed configuration type files which these libraries generate and these build systems understand, and using all of that craft it is able to find that. For input output, can we use the below at top of source code file? You can, but please don't. What are the mandatory components of the make file or CMake file? For CMake, well, this is the bare minimal that you can have. And we are not really going to write make file by hand. We are only going to deal with this CMake part, and this is basically the bare minimal CMake that you can have here. Okay. Now, this part is done, so we will basically start with variables and data types. Okay, so I'll specify it here. Now we come to next topic, variables and data types, because only printing something on screen is not really useful, right? We want to do something else as well. We want to do some possibly number crunching or something like that. Okay, so for that we need two things. We need data types and variables. So we will start with variables, and these are basically named memory locations. What do I mean by named memory location? So basically, whenever I declare a variable, as in I specifically say that, okay, I want to hold some data somewhere in memory. Where exactly in memory? I don't really care. Okay, as long as it is somewhere in memory and is usable for me within the code, I don't really care where exactly in RAM that variable is going to be. Okay, I can have multiple variables, and what compiler will do, it will basically figure out how to put that part somewhere in memory under some constraints. And again, I don't really care about that. I only want that I should be able to refer to some part of memory with some helpful name so that I can recognize its purpose. Okay, that what type of data I have stored there and what is the purpose of that particular data. Okay, and before using any variable, we have to declare variable before we can use it. Now, if someone is coming from languages like Python, where you don't have to explicitly declare variable, you just put the variable name and that variable basically appears in somewhere in the memory. You will probably have the question that why bother declaring it explicitly? Why can't compiler figure out that okay, this is a variable that was not declared, so let us declare a new variable. Okay, uh, can anyone answer this question? Why do we need to declare variable at all? Why can't compiler figure it out? Specifically, especially because there are languages where this thing is done automatically. You can put your answers in that QA chat directly. Anyone? So we can understand what we wrote so that compiler knows the size to allocate. By that logic, Python shouldn't know what size to allocate in memory. Because the compiler is space based on data type. So how does Python does it? Memory allocation, again, Python is doing it. Specific for size for the type, again, Python is doing all of that. Okay, here is the answer. If we do not make this variable declaration mandatory, what happens when using that variable, we accidentally mistype it, especially for assignment type of stuff where we are basically assigning some value in some variable and by mistake we typed something else. Maybe a letter gets omitted, maybe two letters get swiped out, maybe we basically fat finger the keyboard and we type some different letter. In that case, in languages like Python, what will happen that a new variable will magically get created. In languages like C++, your compiler will be screaming at you that, okay, you have used something which looks like a variable, but you have not declared that a variable explicitly. So what happens here, in case of languages like Python, the program will run, but it will not do the expected thing, and then you will have to put quite a bit of effort in figuring out what went wrong until you realize that okay, you basically fat fingered while trying to type the code, and there was a spelling mistake in the variable name. In C++, your program will not even compile. Okay, so that is basically, although it can look like a little bit of pain that you have to declare everything, but in grand scheme of things, that is a pretty good safety net because in C++ you will see a lot of huge code bases. And when the code base is rather large, you absolutely do not want to comb through the code manually trying to figure out whether this is a spelling mistake or indeed a new variable. You want some automated tooling to do that for you, and that is why this is specified to be explicit. It has to be declared specifically. Okay, so now we come to declaration part. So how do we declare it? So generally what happens here is that we specify the data type, and then we specify the variable name, and then we end the line with this semicolon like we have done here. Okay, so semicolon, end of a statement marker in C++. So here basically one particular statement is going to end. Now this is the syntax. Okay. Now there are some constraints on variable name. Constraints on variable name. It has to start with. It has to start with either capital A to capital Z or small a to small z or underscore. Okay, only these are basically allowed. After first character, all of these are allowed. Okay, And there is third constraint. Two variables in same scope cannot have same name. So basically, no name collision. We will come to this part a little bit later. Now we come to the data type. Okay, so there are multiple types of data type basically. Okay, so for example, there are numeric data types. Okay, so there are numeric data types. For example, there is int, there is long, long, or rather we can club it all of these together. Short. Okay, then there is float, double, long double. There is bool for boolean. So these are basically integers. Okay, so these are integers. The only difference is that these will have a different range of values that they can hold. These are going to be decimals. Again, the difference is in the range of values and the precision. This is going to be boolean, as in true or false. Okay, then there are character types because, well, character are how we are going to make a string. So there is char. Okay, one character, 1 byte. Then there are some other special snowflakes like char 8 underscore t, etc. So, but we will not really go into that, at least not here. Okay, and then okay, with these we can have either signed or unsigned. So this basically it is default, and this basically says that variable can hold negative values as well. And if we say unsigned, it says basically variable can hold only positive values. Okay, so the complete syntax basically becomes you specify sign. Okay, then you can specify okay, either you can take it as one data type or you can take it as a specifier. Both are fine. Okay, so now if we want to declare a variable, how we will go with it? This sign part is optional. Okay, so we will put this inside square brackets. It is optional. So I want to declare an integer. So what I will do, I will, okay, I don't want to specify sign. It is going to be signed. So the data type is going to be, let us say I pick int. Okay, so then space, and then I need a variable name. So I can say like this. Okay, I want to declare a character. Again, it is going to be char space, and then it can be some other variable name. Okay, I can declare a boolean as well. Same way, bool, again variable name. Okay, then okay, now I want to declare unsigned integer. What I will do, unsigned int and then a variable name. Okay, so what I will do, let us see if we can declare some variables here and see how that goes. And then we will figure out what to do with the variables that we have now. Okay, so let us start with unsigned num1, num2. Okay, and well, we have variables, but we don't really have anything in those variables, right? So here we want to store something in variables. So store something in variables. So what we can do? We can do num1 equal to some value. Similarly, we can do num2 equal to some other value. This is one option. Second option is that instead of doing it into two separate lines, uh, we can do all of that in one go. So num1 equal to 10, num2 equal to 20. Both are okay. Or we can split it into two separate lines again. Doesn't really matter. These can be declared in one shot as well, as long as all variables are of same data type. So I can't really declare a boolean and an integer in same statement. These are going to be two separate statements. I can write like this. Okay, same line but different statements. But I can't write it like this. This won't work. Okay, now I have variables, I have values. Uh, okay, and now I want to do something with these values. Okay, so to do something with variables, we need operators. Okay, let us do something with variables by operating on values stored in them. Okay, so there are some common operators that you already basically recognize. So, for example, uh, basically arithmetic operators are there. Okay, so there is plus to add numbers, minus to subtract numbers, for multiplication, for division. Okay, similarly, for there are bitwise operators which will basically operate on bits of data. They won't operate on the value as a whole. They will operate on individual bits. So we have negation, we have bitwise, or we have uh, bitwise uh, and okay. Then we have bitwise XOR as well. So here it is, not, or, and XOR. Okay, then we have logical operators. This says not, then it is and, then it is or. So this is not and or. Okay, so this will operate on values. This will operate on individual bits. Okay, then there are operators for comparison. Comparison operators. So there is less than, there is greater than, there is equal to, there is not equal to, there is greater than or equal to, there is less than or equal to. Okay, so basically these are the most common operators that we are going to deal with. Okay, and these will basically let us do something on the data and then eventually basically process our data. So here what I have two numbers. I want to add them. Okay. And for operators, I have one arithmetic operator here. And well, this is an arithmetic operator. It will work exactly as expected. It will basically do arithmetic summation of two values and then give you the result. So what I will do sum equal to num1 plus num2. Okay. And now I want to print the output. So stdc output is sum. Okay. And what I'm going to do, I'm going to do build all, then run. And here I see that output is 30. Okay. So here I am able to add two separate values here. Okay. Similarly, I can do subtraction, I can do multiplication, I can do division. So if I do say multiplication here and I build and run it again, and here I am basically output is 200. 20 times 10, 200. So this is how it is going to work for most part. Okay. Then we will cover these two, these operators basically. And again, these are going to work exactly as you expect them. So suppose I want to compare the values and I want to, okay, so bool is less than equal to num1, num2. And I build it, I run it here, and it says output is 1. So that's basically true. Okay. If I change it to this one, num1 greater than num2, and run it again. Oh, wait. And it says output is 0. So num1 is not greater than num2. Okay. Similarly, I can put some other operators. I can test for equality and run it again. And it says output is 0. That means that num1 and num2 are not really equal. Okay. Now we come to basically these two, and these two work slightly differently. So for wait, logical operators, so they work something like this. Okay, we have input A, we have input B, we have output for, okay, so let us start from one operator at a time. Logical not, and this is this one. So it will convert true to false and false to true. Okay, it uh, takes only one input. Then we have logical and takes two inputs. both inputs are true, result is true. Otherwise, result is false. Then we have uh, logical OR, and this is this one. Again, takes two inputs. At least one input is true, result is true. Both inputs are false, result is false. So this is how these logical operators are going to work. And then we have bitwise operators. And okay, so for this, true is represented by 1, false is represented by 0. Okay, so this is something that you have to keep in mind here. Now we come to this bitwise operators, okay, and these first three are going to work mostly like logical operators, except their input will be individual bits. Similar to logical operators, except they operate on one bit at a time. Output bits are stored in target variable. So what this means basically that if I have something like, okay, so we will just try it out here and then I will explain what is going on. And the only thing is that that XOR is extra here, and XOR is basically it will be true when only one input is true, otherwise it will basically return false. So for bitwise, it kind of works like this. Okay, so let me remove this and num2 and it is 2. Okay, and what I'm going to do is unsigned int result equal to, and I am going to specify num1 or num2. Okay, so what is going to happen here is, let me finish this code here. The result is result. Okay, now this is how it is going to work. So num1 in binary, it is going to be 0000 I am taking only 8 bits here because because most of them are going to be 0 anyway. Then we have num2 in binary. We have 0000. We have 0010. Okay, num2 is 2. Okay, and now we are going to do bitwise OR. So result is going to be like this. So what will happen that it will operate on one bit at a time. So one bit from up, one bit from down. So 0 or 0, both are 0, so it will be 0. And then for 4, 5, 6, for these 6 bits, both sides are 0, so both sides are going to remain 0. Now we have some difference here. One input is 0, one is 1. So for or as long as at least one input is true or 1, result is going to be true or 1. So here this one is 0, but this one is 1. So output is going to be 1. Similarly, here this one is 1 and this one is 0. So output is again going to be 1. And in decimal, it will be basically 3. Okay, so we will just build, and here you see that result is 3. Okay, so this is how these bitwise operators are going to work. Similarly, we can take an example of AND. Okay, and then we can see how it is going to work out. So this is not going to change. And then here we have bitwise and for AND we have both inputs are true, so result will be true, otherwise it will be false. So these are not going to change, both are false. Here first one is false, so it is going to be 0. Here second one is false, so this is also going to be 0. So in decimal it will be 0. Okay, so we will compile it again, and result is 0. Okay, now can anyone tell me why exactly will we need this type of operation? I mean, rest of them are rather straightforward. Arithmetic, well, we need to do some number crunching. Logical operators, well, that makes sense. Comparison, that also makes sense. We need to know at times whether some stuff is beyond certain limits. And for logical, well, obviously we need to know whether certain conditions are getting satisfied. So these three are kind of straightforward. But why exactly do we need this? Anyone? Okay, I see there are some other questions. What are the bitwise operations utilized in real world? Masking is one of the applications. That is correct. Cryptography, not really. Faster multiplication and division. No, that is done by shifting. That is not by bitwise comparisons. That is shifting. Flags, yes. So basically, mask, flag, both are kind of same thing. Okay, so this is where it is used. So the common use is encoding multiple options in minimum space. Basically, one option, one bit. Okay, specifically when your options are going to have only two values, true or false, as in you want to specify whether to enable or disable something, whether to allow or disallow something. Okay, whether to give permission or not to give permission, whether to expose, not to expose, where your choice is going to be basically binary in yes or no type of answer. So one option is that you can basically create one variable for each option, and then you can track separately. That is trivial. But the problem is that if you are going to uh, pass these options around, as in at a startup you did something and you figured out what stuff is to be enabled, what is to be disabled, that sort of stuff, and in rest of the code you are checking for those specific values, whether to allow or not allow, that sort of stuff again. So one option is that you create captain of variables, one variable for each option, and then you pass everything from one function to another, to another, to another, or keep everything in one place. But again, you are going to have captain of variables, and then you will have to check a lot of things. Okay. And then if you want to check for 3 or 4 separate conditions, you will have multiple lines of code only checking for those particular things. So instead of that, what we can do, we can use this bitwise stuff and encode one option in one bit. And for checking, we can involve these bitwise operators to check whether the particular bit is set or not, or to set or reset some particular bit as well. So, for example, okay, I will change it. Mask option and mask. So what I am going to do, I am going to set it to 3. Okay, and now it is 1 1. Mask is going to be option. Uh, mask is this. Okay. Now what I want to do, my all configuration options got encoded into this one variable. I want to see whether the second bit from rightmost side is set or not. Okay, because second bit is not something that I am interested in. So I can do something like this, and here the result will be 2. Okay, so if I run it here, result is 2. And then here after this, I can basically put a check for that particular value, that if that bit is set, I should get 2 in the result. So if I am getting 2, I can say that okay, this particular option is set here. Similarly, in one shot, I can check for multiple options just by specifically setting bits in this particular mask. So if I say that this bit should also be set to 1, okay, and I apply this mask, so I will get basically non-zero value only when in input option at least these 2 bits are also set. Otherwise, I will basically get a 0. So I can set basically a chain of conditions in one shot, saying that okay, I want all these options to be enabled at once. Otherwise, this is not going to work. So I just set the bits, apply that bitwise operator, get the result, and in one shot I know whether all the options are set or not. I don't really care whether 3 of them are set or only 2 of them are set or which particular option is unset. I am not really going to care about that. I only care about whether the entire combination of the options I am interested in, it is set or not set. So in those cases, these operators are uh, quite useful actually. Okay, so there are 2 more operators. This is called left shift and right shift. Okay, so left shift and right shift will basically move the bits either in left direction or right direction. So if I do that left and right shift, so what will happen here? Okay, let me remove this comment. We can do it here. Okay, here you see result is 12. Why? Because, okay, this is this in binary, okay, and we want to shift it by 3 places. It was left shift. So we want to set it by 3 places, okay. So that means 1, 2, 3. 1, 1, 0, 0, 0. And this is 1, 2, 4, 8, 3. Okay, it is going to be this. Okay, correct. Mask consists to, okay, fine. It is going to be shifted by 2 bits. So this comes here this comes here, the result becomes this, and this is 1, 2, 4, 8. 8 plus 4, 12. So yes, it is going to be 12. That is the result we are getting here. Okay, similarly, if I set it to 12 and do this right shift, so here it is 11, 0, 0, and it will become basically 0, 0, 1, 1. And it will come to 3. So it is 3 again because of this bit shifting. And now I suppose you probably already noticed that shifting left and right is basically same as multiplying and dividing by 2. So this is also used for fast multiplication and division. Specifically, if you are multiplying with or dividing by some power of 2. Otherwise, it does not really work that cleanly. For power of 2, you can just shift left or right with appropriate number of bits and you will get the result. So, well, yeah, these are the operators here. Okay. And now, since we are dealing with these variables, data types, and their operators, there is only one part missing, and that is how do I take input, right? Right now, I am specifying the input values manually in the code, building it again, running it again, then modifying it, then build and run. This is not really that useful. I want some way to read this stuff straight from user, and then I don't have to recompile my code again and again and again. I can just compile the binary, distribute it, and then user can be happy while playing with it. So for input, one. Okay, so what I'm going to do, I am going to just remove the assignment, and then I am going to take input. Take input, and for output, we had this console output. For this, we have console input. Okay, and just like this console output, we start like this, and this time the flow of data is in opposite direction. Here we are basically sending this to this console output here. This time we are going to pull data out of console input, so the direction will basically reverse. And we want num1 and we want num2. Probably we should print something to tell that we are waiting for some number. And okay, so here it goes. Okay, so here it is waiting for the input. Say I input 64 for number 2. Let us say I input 3, and the output is basically 8 after shifting. Okay, so this is how we can take input. And now, by the way, if you are confused why the input is getting repeated here after I type it here, especially because I have not printed input anywhere in the code. This is a quirk of this console because I am giving input to this console, and this is basically given to that VM, and that VM console is basically printing it here. If I do it directly from terminal, Mm, oh, crap. It basically died. SSH. E dot E. Okay, so if I do the same thing here, I can do this and do this, and result is it. Here, there is no repeat print because I am attached to the VM terminal directly. Here I am not attached to VM terminal directly, therefore I provide it to this, then it is giving it to VM, and then it is getting the duplicate print here. So you don't shouldn't be getting confused here for this part. Okay, so this is how we are going to basically take the input. Okay, now what I want you to do, you can possibly write couple of programs, and I want you to try basically all these data types. Okay, signed, unsigned, both, and basically all the operators here, uh, except this one. But for example, if you are going to do this for decimal values, you are going to you are going to see some surprises that are really out of scope. So don't do this with decimal values. Don't do this either. So these two should be reserved mostly for integer values so that you can at least uh, reduce by doing something like this to see what exactly is going on, or rather what should go on and what is happening right now. Okay, but these can be used with basically any fundamental data type. These can be used for all the integers and decimals. So what I want you to basically try out pretty much all these data types and try out pretty much all these operators. So you at least have some idea about how these operators are going to work in real life. Okay. And then in next session, we will basically start with conditionals and loops. And we will focus on that simple if statement, if else chain of multiple conditions, switch cases, bunch of different types of loops, that sort of stuff. And we will also slightly expand this variable and data type part in next session. Okay. Any questions? How did this work without using ENDL? Wait, are you talking about this one? See, ENDL is end of line marker. So if I use this and then I print something else, that will go into new line. I don't really need it here because while providing the input, I will have to press enter anyway, right? So if I am pressing the enter, the cursor will go to the new line, uh, and then this will print on that new line. I can specify ENDL here, but then we will start seeing some blank lines here. It is not really required to get something printed. Please post this document. What document? Do you mean this plain text notes file? That I will share. Sir, when we are going to start with core automation, that will take at least 3 to 4 weeks before we start seeing at least some automation, because I have to build up at least language basics before that. So can we deduce that sessions shall be on weekends? Yes, and only on Saturdays, unless specified otherwise. How we will be able to see the recording will be notified and recording available on Academy? I think Animesh will be able to answer that.
Yes. So once the session ends, you will be receiving another email from our side with the recording links and the password. I hope that answers your question.
So I have copy pasted that plain text notes that I was typing on the screen in the chat. So you can probably copy it from there. Can we have a discard for this subject automated with C++? I think Animesh will be able to answer that.
So currently we do have a Discord server, and the email was only sent to the people who was you know came through support or support plus plus plans. But we can enable it for everyone. So once I get the report provided, I'll send out an email with the invite link. They can join join the Discord as well.
No more questions? So I will send the name of books as well. So complete reference, and the second one is C++ primer. So these are the books that you can purchase and refer to in parallel. Okay, see you on next session then. And from next session, we will hopefully pick up a bit more pace because we won't have to talk about setting up the expectations and where basics. I expect you to be prepared with whatever we discussed today.
Thank you everyone for joining our 2 hour long session. In case if you have any questions or anything, feel free to reach out to me and I'll have your answers ready. Thank you everyone. Have a great weekend. Yes, Tanish. Mr. Now we can end this call.
Sure, sure. I'm not sure where how to end this session.
Okay, I'll do that. Thank you
Sure, sure.
everyone. Have a great weekend. See you soon. Bye bye.